Hey everybody, the purpose of this video is to get you some solutions to the Ben snowfall quiz, the February 8th, which was that crazy snowfall we had earlier this year. If you're watching this in some other year, this is 2014. Hopefully we can use this video for a few years. Anyway, it was interesting because we got so much snow in one day, and I was curious how that actually affects historical snowfall data. And what's cool is, as I was pondering it, shoveling my driveway off that day and then my in-laws' driveway, I went in to send myself an email to remind myself to make this quiz, and a few other students had also sent me, hey, I wonder if. So anyway, kind of a fun little idea. So the first one, we've got 91 to 2013. The average was about 2/10 of an inch. So that's the first bit of data, 91 to 2013. We had an average over that period of time of about 2/10 of an inch. Okay? In 2014, the average, if you will, was 25 inches. Now, it seems silly to call it an average, but it is an average. It's an average with a sample size of 1. This is an average with a sample size of 23. So, I mean, if you think about it, you can totally have a sample of 1 and have its average. It's the 25 inches. I have that right? I do. 25 inches is what we got at my house. So, now the question is, what's the average from 91 to 2014? Now, it's tempting to add 25 to 25.2 divided by 2 and call that the average. But the problem with that is, that makes it seem like there's only 2 years. This one and that one. But what is that one? Well, that one's actually over the course of 23 years. There weren't 0.2 inches of snow that fell between 1991 and 2013. There was an average of 2/10 of an inch that fell. So what you have to do is you have to weight the average, much like we did in class. Now in class, we had an X column and we had an F column, like this. Well, you can do the exact same thing with averages. And one of the, in the extra resources page, you'll see a GPA question, which this is the same as. So all you have is you have 2 averages. You've got 2/10 of an inch and you've got 25 inches. The frequencies of these are simply the sample sizes. This happened over 23 years, this happened over 1 year. And then to figure out your average from 91 to 2014, you simply do the weight times the average. So you're going to have 23 times 0.2 inches plus 1, or ignore, times 25 inches. Put that in parentheses if you want. Divided by how many years we have, which is 24 in total. 24 in total. And this works out, I used Google to calculate this because I can't do math, as you've seen, about 1.2 inches on average, which is amazing. Now, it's amazing, but it's not surprising. Remember what an average is. It's a sharing of data. So when all that 25 inches fell on February 8th, essentially what this calculation does is it takes that 25 inches and spreads it equally over all 24 years. It's about the same, right? 25 inches, 24 years. Essentially, every year got about an inch, a little smidge more. So when the average was 0.2, it's now about 1.2 because each year picked up 1 more inch than it had previously, average-wise. Okay? I also want to talk about one thing that might be freaking you out. I made a comment earlier how in class we were calling this X. You can easily call it X bar and all as well. But why does this work? Well, if you go back to the formula of what an average is, an average is all the data summed together divided by your sample size. Okay, that's the if you will, the idea, the shortcut formula. Well, if you solve that and get the summation of X on one side by itself, you get N times X bar, which is the summation of X, which again might just seem like mathematical mumbo jumbo, but realize that's what you see here. N times X bar, N times X bar. So what you're looking at is the summation of all the X. So what you're looking at is all the snow that fell over that time period. So 23 times 1/5 of an inch gives you the sum total of all the snow that fell between 1991 and 2013. And 1 times 25 inches gives you the sum total of all the snow that fell on February 2014. So when you add this to this, what you're essentially getting is all the snow that fell between 1991 and 2014, which is exactly what you want, right? You want all the snow that fell between 91 and 2014. divide it by how many years, and it gives you your average. And that's why it works. That's why it works. I mean, mathematically. Logically, hopefully it works just by logic. In your mind, hopefully you've made peace with that. But mathematically, that's why it's legitimate. Cool. Okay, same deal for, I go back in time a little further with this next one, and we go from, it looks like, 28 to 2005. So I told you to go 28 to 2005, but skip over 2006 to 2013. I think the reason I had you skip that was I didn't know what it was between 2006 to 2013. Like, I knew what it was from 91 to 2013, but there was no graphic that I could look at that showed me the 2006 up to 2013. So just leave it off altogether. But it's the same idea. It's the same idea. You've got a frequency, you've got 78 years. You've got 78 years. So here's, oh, that should be next bar. Apologies. Now we're going 1928 to 2014, not including 06 to 13. Okay? So we had 78 years, yes. And over that period of time, we had a 3/4 of an inch average. 3/4 of an inch average. Plus, we had 1 year again, where there was a 25-inch average. So that's 79 years altogether. And the same logic applies here. Same exact logic applies in that this is telling you how much total snow fell between 1928 and 2005. Yes, I believe. Yes, 2005. And that tells you how much total snow fell. So when you work this out, again, I had Google do it for me because I can't do math. I got about 1.1 inches. 1.1 inches, which is fairly consistent with the 1.2 from before. What I find interesting is that there was a drop in the average snowfall from 91 to 2014, but if you go back in time, the average snowfall was higher. Now again, using an average in this case, I'd like to see all the individual data points. I don't know which ones they used. We'll play with this more in class with more precise data, actually more localized data, I guess. But this is a good start for how to, again, weighted averages are probably the most important kind of average you can do. Because it permeates all of statistics and all of your life. It permeates your insurance payments, it permeates how much you're paying for your cell phone bill, your cell phone plan, it permeates your health insurance, it permeates so much of what is in your life. Descartes used it to prove the existence of God, which is kind of fun. Anyway, it permeates so much. Obviously, if you can understand a weighted average, the world opens up to you in ways that that you might not otherwise be able to understand. A big one that just came up for me, and remind me to tell you this in class, I think I mentioned it already, is the idea of a high deductible health care plan. Weighted averages are a way to understand whether or not you should use that. So anyway, we're about to embark on this whole idea in class in the next couple weeks. So I hope this was a good start for you, and I hope it made the quiz problems make more sense. See you in class.